Space looks peaceful from here. You look up at night, you see stars, maybe the moon. It feels quiet, almost comforting, like the universe is just sitting there, minding its own business. But the further out we look, the more powerful our telescopes get, the deeper we peer into the darkness, the more we find things that have no business existing, things that break the rules, things that are so large, so violent, so fundamentally wrong by every measure of human intuition that scientists genuinely struggled to believe their own data. Today, we're going into the deep, past the planets, past the stars, past the edge of what feels safe. These are the scariest things we have actually discovered in deep space, and not one of them is science fiction. Let's start with something relatively close to home. Relatively. Magnetars are a type of neutron star, a collapsed core of a massive star that exploded. They're incredibly dense. A single teaspoon of magnetar material would weigh about 1 billion tons on Earth. They're only about 20 kilometers across, smaller than most cities, but they contain more mass than our entire sun. And their magnetic field is where things get truly terrifying. A magnetar's magnetic field is roughly a quadrillion times stronger than Earth's. To put that in perspective, if a magnetar were positioned halfway between Earth and the Moon, it would strip the iron from every red blood cell in your body from that distance. You would not need to be anywhere near it. It would kill you from 200,000 kilometers away. In 2004, a magnetar 50,000 light-years away, on the other side of our galaxy, released a burst of energy that lasted just 0.2 of a second. That single burst released more energy than our sun puts out in 250,000 years. It was so powerful, it partially ionized Earth's upper atmosphere from across the galaxy. From 50,000 light-years away, something that far away affected our planet. That is what a magnetar is capable of. Here's something that should unsettle you. Our galaxy, the Milky Way, is moving, not just spinning, not just drifting. It is being pulled hard toward a single point in space at roughly 2.2 million kilometers per hour. And it's not alone. Dozens of galaxy clusters, thousands of galaxies in total, are all being dragged in the same direction, toward the same point. Something is out there pulling on an almost incomprehensible scale. We call it the Great Attractor. And here's the part that keeps astronomers up at night. We can't see it. Not because it's invisible in a mysterious sense, but because it sits almost perfectly behind the densest part of our own galaxy, obscured by billions of stars and clouds of dust. The Milky Way is blocking our view of whatever is pulling us toward it. What we do know is that it sits about 250 million light-years away, and its gravitational pull is equivalent to the mass of tens of thousands of galaxies. Estimates suggest it could be a massive supercluster of galaxies, the Laniakea supercluster, of which the Milky Way is just a tiny outer member. We are falling towards something enormous. We have been for billions of years, and we will never arrive because space itself is expanding faster than we're falling. But the pull is real, the motion is real, and whatever is causing it is one of the largest structures in the known universe. You probably already know black holes exist, but do you know what sits at the center of almost every large galaxy in the universe, including ours? A supermassive black hole. Not a regular black hole, not a stellar black hole the mass of a few suns, a supermassive black hole containing millions or billions times the mass of our sun, compressed into a single point in space. At the center of the Milky Way sits Sagittarius A star, a black hole with the mass of 4 million suns. It is 26,000 light-years away from Earth, and it is, by cosmic standards, relatively quiet right now. But some galaxies have active supermassive black holes, called quasars, that are actively consuming enormous amounts of matter. The most powerful quasars shine brighter than entire galaxies, containing hundreds of billions of stars. One quasar discovered in 2015 is so luminous it outshines our entire Milky Way by 400 trillion times. And the black hole powering it? It grows by the equivalent of 2,000 suns every single year. Every year, 2,000 suns gone. When scientists map the oldest light in the universe, the cosmic microwave background, the faint afterglow of the Big Bang, it's remarkably uniform, smooth, consistent, which is exactly what our best models of cosmology predict, except for one spot. In one region of the sky, there's a patch of space roughly 1.8 billion light-years across that is significantly colder than everything around it. Not slightly colder, measurably, dramatically, inexplicably colder. It contains far fewer galaxies than it should, far less matter than anything nearby. It is essentially a supervoid, an enormous empty region of space that our current understanding of the universe cannot fully explain. The most conservative explanation is that it's simply a very large cosmic void, a region where matter happened to cluster elsewhere, leaving this area unusually empty. The more provocative explanation, proposed seriously by actual cosmologists, is that it could be evidence of another universe, that our universe may have collided with a neighboring universe in the distant past, and the cold spot is the bruise left behind, a scar on the fabric of space from a collision with something we can barely even theorize about. No one has proven that, but no one has disproven it either. If you were asked to design the most destructive event possible in the universe, you probably couldn't top what nature already came up with. Gamma-ray bursts are the most powerful explosions we have ever detected. They occur when certain massive stars collapse or when two neutron stars collide, and they release in just a second more energy than our sun will produce over its entire 10-year lifetime. They fire a focused beam of gamma radiation across space at the speed of light, and if one were aimed at Earth from within our galaxy, even from thousands of light-years away, it would strip away the ozone layer on the side of Earth facing it, expose the surface to lethal radiation, trigger a global collapse of the food chain, and potentially cause a mass extinction. Some scientists believe that a gamma-ray burst may have actually caused one of Earth's past mass extinctions, the Ordovician extinction, 450 million years ago, that wiped out 85% of marine species. The good news, the ones we detect are almost all in other galaxies, billions of light-years away. None of the known candidates in our galaxy are pointed at us. Almost. Magnetars that could kill you from across the galaxy, an invisible force pulling our galaxy towards something unknown, black holes swallowing the equivalent of 2,000 suns every single year, voids that might be scars from collisions with other universes, explosions powerful enough to sterilize planets from thousands of light-years away. All of that is genuinely terrifying, but none of it is the scariest thing we've found in deep space. The scariest thing is what we haven't found. The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. A significant portion of those stars have planets. Many of those planets are inhabitable zones, with liquid water, with the conditions that produced life here on Earth. By every statistical measure, the universe should be teeming with intelligent life. Some civilizations should be millions of years more advanced than us. They should be detectable. Their signals, their megastructures, their footprint on the cosmos should be visible. And yet, silence. Complete, total, unbroken silence. We have been listening for decades. We have scanned millions of stars. We have found nothing. Either intelligent life is so rare that we are genuinely alone in a universe of 2 trillion galaxies, which is its own kind of terrifying, or something happens to intelligent civilizations before they can make themselves known, something that gets every single one of them, every time, without exception. We don't know which answer is true, and honestly, both of them should keep you up at night. The universe is not the calm, beautiful backdrop it appears to be from your backyard on a clear night. It is violent, it is vast, it operates on scales and with forces that human language was simply not built to describe. And the more we look, the more honestly we look, the stranger and more humbling it becomes. But here's the thing about it all. The magnetars, the black holes, the silence, the cold spot, the gamma-ray bursts. None of it has stopped us from being here, from asking questions, from pointing our telescopes outward and demanding answers from a universe that gives them up slowly and reluctantly. That might be the most remarkable of all. This is Cosmic Earth. If the universe scares you and fascinates you in equal measure, you're in the right place. Subscribe and let's keep going deeper into the dark.